Welcome to Cosmic Discoveries. Hello, fellow travelers. Welcome to Cosmic Discoveries, where we venture into the vast, mysterious universe, exploring its most captivating secrets. Today, we'll be embarking on a thrilling journey through the history of one of the most revolutionary theories in all of science, quantum mechanics. Fasten your seatbelts, because we're about to dive headfirst into a world where energy comes in tiny packets, particles behave like waves, and our very understanding of reality gets turned upside down. Get ready to have your mind blown. Picture this. It's the early 1900s. Scientists are feeling pretty confident. They think they've figured out most of the universe's mysteries. Newtonian physics elegantly explains the motion of planets and stars. Maxwell's equations have demystified electricity and magnetism. It seems like science is on the verge of unlocking all of nature's secrets. But then a few cracks started to appear in this seemingly perfect edifice of classical physics. Experiments started yielding results that just didn't make sense. A strange new world was lurking beneath the surface, waiting to be discovered. This was the dawn of a new era in physics, the quantum revolution. Our journey begins with a German physicist named Max Planck. In 1900, Planck was wrestling with a problem that had been stumping scientists for years: blackbody radiation. A blackbody is an idealized object that absorbs all light that falls on it. The problem was that classical physics couldn't explain the spectrum of light emitted by such an object. Planck found a solution, but it was a radical one. He proposed that energy, instead of being continuous, was actually emitted in discrete packets or quanta. He even gave these quanta a name: photons. This was a revolutionary idea, like saying you could only climb a ladder one step at a time, not smoothly slide up. The next stop on our quantum journey brings us to a young Albert Einstein. In 1905, Einstein used Planck's quantum hypothesis to explain another perplexing phenomenon, the photoelectric effect. This effect describes how light shining on a metal surface can knock electrons loose, creating an electric current. The strange thing was that the energy of the ejected electrons depended only on the frequency of the light, not its intensity. This made no sense according to classical physics. Einstein realized that light wasn't just a wave, it was also a stream of particles, those photons that Planck had proposed. This was a huge deal, as it challenged the long-held belief that light was purely a wave phenomenon. Fast forward to 1913, where we meet Danish physicist Niels Bohr. He took the quantum idea even further by applying it to the structure of the atom itself. At the time, the atom was pictured as a miniature solar system, with electrons orbiting the nucleus like planets around the sun. However, classical physics predicted that these orbiting electrons should continuously emit radiation and spiral into the nucleus, causing the atom to collapse. Bohr proposed a radical solution. Electrons could only exist in specific quantized energy levels around the nucleus. They could jump between these levels by absorbing or emitting photons of specific energies. This model, though later refined, revolutionized our understanding of the atom. Through the looking glass, the double-slit experiment. No exploration of quantum mechanics would be complete without a visit to one of the most mind-boggling experiments ever conducted, the double-slit experiment. This experiment, first performed with light and later with particles like electrons, revealed the truly bizarre nature of the quantum world. Imagine shining a beam of light through two narrow slits. You'd expect to see two bright bands on the screen behind. Right? Well, that's not what happens. Instead, you get an interference pattern, a series of bright and dark bands, as if the light waves are interfering with each other. But here's the kicker. Even when you fire single photons, one at a time, the interference pattern still emerges. It's as if each photon somehow passes through both slits simultaneously, interfering with itself. This wave-particle duality, the idea that matter can behave as both a particle and a wave, is one of the most fundamental and baffling principles of quantum mechanics. Section 7. Quantum mechanics, the engine of the modern world. The discoveries of Planck, Einstein, Bohr and others opened a Pandora's box of quantum weirdness. But this new understanding of the universe wasn't just a mind-bending exercise. It had profound implications for technology, leading to the development of countless devices that define our modern world. Take lasers, for example. These devices, which rely on the quantum phenomena of stimulated emission and energy level transitions, are ubiquitous in telecommunications, medicine and entertainment. Then there are transistors, the building blocks of computers and smartphones, which rely on the quantum properties of semiconductors. And let's not forget medical imaging techniques like MRI, which exploit the quantum properties of atomic nuclei. These are just a few examples of how quantum mechanics has revolutionized our lives. Section 8. A universe redrawn. The journey through quantum mechanics has been a wild ride, hasn't it? From Planck's hesitant first steps to the mind-boggling implications of the double-slit experiment, we've seen how these discoveries forced us to rethink our understanding of the universe. The deterministic, predictable world of classical physics gave way to a stranger, more probabilistic reality where particles can be in multiple states at once and the very act of observation can influence the outcome of an experiment. Quantum mechanics has not only revolutionized science, but has also profoundly impacted our philosophical outlook. It has shattered our preconceived notions about the nature of reality, causality, and even the limits of human knowledge. The universe, it turns out, is far stranger and more wonderful than we could have ever imagined. Section 9. Thanks for watching Cosmic Discoveries. Well, that concludes our adventure into the fascinating world of quantum mechanics. We've traveled from the birth of this revolutionary theory to its profound impact on technology and our understanding of the universe, but this is just the beginning. The quest to unravel the mysteries of the quantum realm continues, promising even more astonishing discoveries in the future. Thanks for joining me on this episode of Cosmic Discoveries. Don't forget to like and subscribe for more mind-blowing explorations of the universe. Until next time, keep looking up and keep asking questions.